Hey everyone, it's Miss Bell here again from the Science Lab, and today we're going to be talking about speed. Now with speed, in order to use that speed formula, you're going to need to know the distance for how far an object travels, and you're going to need to know how long that item takes to get from one place to a different place. So we're going to be using meter sticks and stopwatches with our battery operated cars, and this lab is pretty cool and I had fun working in the lab. Hopefully you guys will have fun too. So with this lab, you are going to be taking a battery powered car and you're going to be turning it on, and the wheels are going to spin around, and you're going to measure on the grounds. You're going to have a starting position and a finishing position, and in between the start and finish you're going to tape off and measure every 100 centimeters. So starting with 100 centimeters, be 100, 200, 300, 400, 500 centimeters. Tape all along. So when you turn on your car and you place it on the ground, your car will be riding alongside or parallel to your markings. Now your car, when you turn it on, the wheels are going to start spinning, of course. And this needs to already be happening before you even put your car down on the floor. So you turn it on, you let the wheels spin, you hold it barely above the ground, and then you count off. Ready, set, go. And as soon as you say go, you place your car on the floor and then allow it to roll, so that the wheels are already spinning and rolling, so that when you start your time, you don't have to wait for it to slowly gain speed, because it already has the speed. It just needs to make contact with the floor. Now, you're going to have people along each of these measurements, and they're all going to have a stopwatch like this, and they're all going to be measuring the time when the car passes at their specific length. So everyone needs to start their stopwatch at the same time when the car drops at 0 time and 0 centimeters. And then when the car comes to this length, 100 centimeters, that person stops their stopwatch. As the car continues on, that person at the 200 centimeters will stop their time. And the same at the 300 centimeters. And then this person stops their stopwatch, and then at the very end that person stops their stopwatch. So everyone should have 0 time at the 0 centimeters mark, but all of the different times should be different as the car is moving in a straight pathway going forward on your measured out lane. Now here you can see our different trials. I did one trial and these were my time measurements. Here's my second trial measurements, and then here's my third trial measurements. And for the most part, they're pretty much very close to each other. Just a second or even less between each other. So none of these are minutes, these are all seconds from when it took for when we dropped the car to when it passed by whatever length. So here I am looking at all of the times for all 3 trials where the stopwatch stopped at 100 centimeters. So first trial, second trial, third trial. And what we're trying to do is figure out the average time between these 3 times. So we need to add up all 3 times and then divide it by 3, because there's 1, 2, 3 times. So here we go. 2 seconds and 40 hundredths of a second, 2 seconds and 34 seconds of a hundredth, and 2 seconds and 47 hundredths of a second. I'm going to add all of those. But before I do, I'm gonna just make a dashed line going all the way down. And on the left of my line, this represents seconds, and this represents hundredths of a second. So here we go. 4 plus 7 is 11. Carry over my 1. 1 and 4 is 5. 5 and 3 is 8. 8 and 4 is 12. Over here on the left, 2 and 2 is 4. 4 and 2 is 6. So this looks like 6 seconds and 121 hundredths of a second. But this is odd. This isn't right. This side is only supposed to have less than 100 seconds. So I need to take my 121 and I need to subtract 100. Because 100 in this sense will equal 1 second. This is like regrouping. I'm going to take 100 off of this side and add it over here eventually. 121 minus 100 gives me 21 left over. So 121 on the right side is equivalent to 1 second and 21 hundredths. So I take my 6 seconds over here and I add that 1 second and 21 hundredths, and I'm left with, starting from right to left, 1, 2, and 7. So 7 seconds and 21 hundredths of a second. But this is adding up all of the times, and we're not done yet. We have to divide by 3. Here we go. 7 seconds and 21 hundredths divided by 3. 7 divided by 3 is 2. 2 times 3 is 6. 7 minus 6 is 1. Carry down my 2. I now have 12. 12 divided by 3, oh, that's so easy, 4. 4 times 3 is 12. 12 minus 12 gives you leftover 0. Nada. Carry down my 1. 1 divided by 3 cannot happen. 0. 0 times 3 is 0. 1 minus 0 is 0. Oop, is 1. Silly Miss Bell. But I'm going to go one step further. So now I have, that's a 10, not a 100. 10 divided by 3 is 3. 3 times 3 is 9. 10 minus 9 is 1. And I'm going to be done. Because we're rounding to the nearest hundredths, I went one step further into my thousandths. So 2 seconds and 403 on the right side will give me 2 seconds and 40 hundredths. Ah, ding, 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 ding. There we go. Now, if you were to check this with a calculator, you can definitely do so. Let's see. Here I have 2.40. I'm adding 2.34. I'm adding 2.47. And that gives me, even though we came up with 6 seconds and 121, look over here. Here, 7 and 21 hundredths. Correct, correct, correct. Here we go. Now we're going to take that 7.21, divide it by 3, and what do we get? 2.4033. Repeating, but we're rounding to the nearest hundredth, which is that place right there. However, you need to look at the next place. The 3 is not going to round up, so you're stuck with your answer that we came up with. So now that I've calculated all of the average times, I'm now going to create a graph. And the graph I'm about to make will plot the total distance versus the average time. I'm going to label the x-axis as my average time. That's the one that goes side to side. And I'm also going to label my y-axis as my distance. That's the one that goes up and down. I also need to be aware of my maximum measurements before ever writing my number increments, because this will help me determine the scale that I need on both my x-axis and my y-axis. I must also write both labels as well as write in my numbers. Then I can start plotting all my coordinates from my chart that I just filled out. I even made a key that is color-coded differently for each trial. As I mentioned, the times are quite close together. And finally, I can use a ruler to draw a straight line for each trial that best fits going through the plots. The line needs to be straight, but don't really worry if the line doesn't touch all of the points. Now I'm going to make a chart and fill it all in with the information that I already know. All of my different distances and all of those average times that we calculated. And then I'm going to use the speed formula of distance divided by time in order to figure out all the different speeds. So I'm going to take my distance, 100, I'm going to divide it by my average time. I'm going to write that as 2.4. When you're dividing by a decimal, remember you need to move that decimal over as many spaces as you need to, and that also means that you have to move the decimal inside the division sign. So my decimal ended up here, so right above, that's where my decimal is going to be. 1 divided by 24, can't do that. 10 divided by 24, can't do that. 100 divided by 24, I can definitely do that. About 4 times. 4 times 4 is 16, carry over my 1. 4 times 2 is 8. 8 plus 1 is 9. 100 minus 96 will give me 4. I bring down my 0, and I now have 40. 40 divided by 24, well, 24 can only go in once. So 1 times 24 is 24. 40 minus 24 will give me 10 minus 4 is 6. 3 minus 2 is 1. 16. I also have to bring down another 0. So 160 divided by 24, well, it can go in, let's say, about 6 times. 6 times 4 is 24. Carry over my 2. 6 times 12. 6 times 2 is 12. 12 plus my carryover 2 is 14. Subtract. 10 minus 4 is 6. 5 minus 4 is 1. I'm going to carry down another 0 because we are going to be rounding to the nearest hundredths. Oh, and look, 160. I already did that before, so I know my answer is going to be repetitive over and over and over. So 41.6 repeated is the same thing as 6 and then 6 and then 6 and then 6 and then 6. But remember, we're rounding to these two places. So that would be 41.67. That is my speed, of course, centimeters per second. And that's it. As soon as you finish all of the division for each of your distances, you are able to take those calculations and input them into your chart. And voila! You're done! Dun, 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 dun.